Hello again, folks. This is Barry with Barry's 8-Track and Classic Car Radio Repair, and I have an interesting little subject to talk about today. It concerns the human hearing range and the frequency response of the 8-track format, which any 8-track enthusiast probably already knows that the 8-track is generally lacking in high-end response, high-frequency response, and to an extent that is true, very true. And as an introduction to that, we're going to go into the human hearing range, which, with a young child who's has not been exposed to a lot of damaging sound levels, the human hearing range is understood to be between 20 and 20,000 cycles per second. That's vibrations per second. And as we age, our high frequency response tends to drop off. And so if 8-track enthusiasts are reading about the 8-track format and are trying to decide which machine to buy, which decks to buy, they may be put off by the fact that a lot of tape decks don't go any higher than about, say, 12 or 13,000 cycles per second, or 12 or 13K. So what we're going to do today is we're going to demonstrate using my acoustic response analyzer. We're going to demonstrate. I'm going to let you hear the actual frequencies, and so you won't get too bent out of shape by the fact that the 8-track format is a little bit lacking in high-end response. And I'll give just a brief little description of the frequency response range. The low end of 20 vibrations per second, we don't really lose that as we age. At those frequencies, it's really more felt than heard. So what we're going to be concerned with mostly is our high frequency response. And this little acoustic response analyzer just happens to be within about the exact same range as the 8-track format. For this demonstration, we're only going to go down to 100 hertz, or 100 cycles per second. We're going to go up to 12,500 cycles per second, which is really just over halfway through the human hearing range, assuming that we're supposed to hear up to 20,000 cycles per second. You might be surprised to know that even at 10,000 or 12,000 cycles per second, at our age, we're probably not really hearing that range anyway. So I'm going to basically just feed an audio frequency into this analyzer. It's going to automatically sweep up from 100 hertz to 12,500 hertz. And one thing neat about this machine is it's kind of a frequency selective VU meter. Like this particular meter, this is assigned to the 1,000 hertz range, and so this meter is only going to register on a tone that's right in that range, 1,000 cycles per second. And so as we sweep up through the audio hearing range, you'll see the first meter is going to register, and then as it starts to fall off, the next one's going to register, and as it starts to fall off, it'll just keep going up the line. And these meters kind of go left to right as if you're reading a book. We got 100 hertz here that goes up to 312, and then here starts over at 400 hertz, goes up to 2,000 hertz, and then the next meter after that is 2,500 hertz, and so on up the line until we reach 12,500 hertz. So what I'm going to do now is I'm going to start the sweep in motion, and you might be surprised to see that you really can't hear the frequencies, even within this limited range. We're not hearing very well 10,000, 12,500. So we're just going to go ahead and start the sweep now. And the first meter that will register will be this one here. And then you just kind of read them from left to right, and you'll see the meters registering as the tone falls within that frequency, that meter's frequency range. So here we go. Going to start our sweep right now. I'm just going to wait a few seconds for the sweep to fall within the range of this. Here we go. All right, now we're starting to register. There we go. Okay, now we're starting on this end. Okay, starting over here. Now, right about now is where we're not able to hear it anymore, and because of the type of sweep I'm doing, this meter is not registering the 12,500, but I'm going to change that sweep Right now we're doing a logarithmic sweep, which basically matches the human ear's inaccuracies. Okay, once again, once we reach this range, we're really not hearing it very well because we're getting old. We've been exposed to damaging sound levels, especially if we're into loud music. And after this sweep, I'm going to switch to a linear sweep, which will go all the way up to this range, but it'll sweep through the lower frequencies too fast for the meters to really register that. Okay, so now we're going to change to a logarithmic sweep, and rather than reaching the high end of the frequency range and then starting over from the logarithmic sweep is going to start ramping down after it hits this high frequency. It'll start ramping down, so you'll see the meters kind of moving backwards. We'll let it go through this logarithmic sweep one more time. Okay, now we're going to switch to linear sweep. Just like that. And so now we're going to be covering mainly halfway on up to the highest. And then it's going to start ramping back down after it hits the highest frequency. So here we go, just follow my finger here. You can see these meters registering. And it's going slowly because we're at the high end of the range. That's the characteristic of a linear sweep, is our ears think it's sweeping a lot slower than it actually is. Okay, so we've got the highest. Now we're going to start ramping back down. When this meter starts falling off, I think it's sticking, there we go. Now this one's starting to register. This one will fall off and this one will start to register, and so on and so on. And see, we're still not really hearing the frequency. Now we're starting to hear it clear down to about 7,000 to 8,000 cycles per second is where we're finally starting to hear it. Incidentally, the highest note on a piano is right here, about 4,000 hertz or 4K. So anything above that is just going to be harmonics that give music its brilliance, but that we don't perceive as actual fundamental notes. As you can see, these meters are registering, but we're just not hearing it. It's too high for us. And we're going to start hearing it in a few seconds as it comes down within our range. And here we go. Now we're hearing it. Going to run through the sweep one more time. Okay, we pretty much stopped hearing it right about 10K. We're at 12.5K now. We're approaching that, and we're just not hearing it. Okay, I think that's a pretty adequate demonstration of the human hearing range and the limitations of the 8-track frequency response. And so I hope this has been kind of an informative thing for you. This way, if you're looking up specs on 8-track players, if you're in the market for one, you really don't need to be too concerned about the lower ends of the limited high frequency response of the 8-track format, because at our age we're really not hearing much past 10K anyway. The cheapest 8-track decks they go up to about maybe 12K, and the very high-end decks go up to about 15K. But really, there's not a whole lot of difference as far as what we're actually hearing. A deck that drops off at 12K is probably going to sound to our ears just as good as a deck that goes all the way up to 15K. So, with that being stated, I hope you've enjoyed this little informative demonstration. This is Barry's 8-track and classic car radio repair. If you have an 8-track in need of service or a classic car AM radio you would like converted to FM, you can reach me directly at 928-533-9666. My website is barry's8trackrepair.com. That's BARRYS number 8 trackrepair.com. And if you'd like a website that's easy to remember, you can also reach me at classiccarradiorepair.com. Thank you very much for watching and listening. We'll see you next time.